Hello and welcome to Network Basics Series. Today's class is Address Resolution Protocol, ARP. Okay, we will go over our learning objectives. Then we'll go over why do you need it. We'll have some exercises, a learning verification, and then the summary. Now, learning objectives. Okay, after going through today's lesson, you will understand what do hosts use Address Resolution Protocol ARP for? What do hosts use Ethernet addresses for? What destination Ethernet address is used when host X must send traffic to host Y in the same subnet? Host Z is the default gateway. What destination Ethernet address is used when host X must send traffic to host D in another subnet? Host Z is the default gateway. Can a host communicate to another host that does not have an entry in the ARP table? As an end user, is the MAC address of a website such as google.com useful to you? Why does ARP timeout cached entries? Why does the reachable time vary between 15 and 45 seconds on Windows? What entries are present in an ARP table on a Windows host? How can the ARP table be viewed on a Windows host? How can the interface index be viewed on a Windows host? How can the ARP timeout value be viewed on a Windows host? Now, why do you need this address resolution protocol? Well, it provides this dynamic mechanism so you can translate protocol addresses such as your IPv4 address to local addresses such as Ethernet addresses. There is not a one-to-one correspondence for the IP address to the Ethernet address. Exercise 1 of 12. Using Address Resolution Protocol. What do hosts use Address Resolution Protocol for? Well, it's used by hosts to translate IP addresses to Ethernet addresses. Then the obvious follow-up question, what do hosts use Ethernet addresses for? Hosts use Ethernet addresses for host-to-host communication. Exercise 3 of 12. Same subnet, destination Ethernet address. Now, what destination Ethernet address is used when host X must send traffic to host Y in the same subnet? Here in our diagram, we have here the host X, which needs to send something to host Y. What destination Ethernet address is host X going to use to transmit to host Y? Host Z here is your default gateway. In this case, for host X to send traffic to host Y inside this same subnet here, host X will send the traffic to the Ethernet address of host Y. Exercise 4 of 12. Different subnet destination Ethernet address. Now, what destination Ethernet address is used when host X here must send traffic to host D, which is in another subnet? Host Z is the default gateway. What destination Ethernet address is used in this scenario? In this case, host X will send to host Z's Ethernet address in order to communicate with host D in this other subnet. Now, exercise 5 of 12. Host communication, no ARP entry. Can a host communicate to another host that does not have an entry in the ARP table? Well, in general, no. We have to keep in mind that a host can communicate to another host that does not have an entry in the ARP table via a broadcast communication. For example, this would how a host would be able to contact the DHCP server when it doesn't have an IP address and doesn't know what the DHCP server IP address is. It would just broadcast and say, help me out here. Now, most applications will not work via broadcast and will instead work via unicast. For these applications, the host will not be able to communicate without a corresponding ARP entry. Please note, even broadcast addresses have an entry in the ARP table. Exercise 6 of 12. MAC address of a public website? As an end user, is the MAC address of a website such as google.com useful to you? Actually, no, it's not useful at all. And this will become more apparent once switching and routing are studied in later lessons. Exercise 7 of 12. ARP timeout. Why does ARP timeout cached entries? Well, ARP uses a timeout cache so that the information is not held indefinitely. Since stations can come and go from the network, other stations could pick up that same IP address. ARP helps to refresh that information periodically, as manually maintaining this network state information would be very labor intensive. Exercise 8 of 12. ARP timeout value. Why does the reachable time vary between 15 and 45 seconds on Windows? Well, it's because there's a random multiplier. Because there is a base reachable time of 30 seconds, but then there's a random multiplier that could range from 1/2 up to 1.5. And because of that, the caching could last from 15 to 45 seconds. Now, the reason for this is because there's a chance that if you didn't have a random multiplier here, all stations may sync up their ARP caches simultaneously, and then all of them would try to refresh simultaneously, and then you could end up flooding the network with traffic because everyone needs to refresh their ARP caches at the same time. It would lead to issues in communication, obviously. Exercise 9 of 12, ARP table entries. What entries are present in an ARP table on a Windows host? Well, as can be seen here in this example, you will have entries for a broadcast address, multicast address, default gateway. Make sure you notice that you will see IP addresses and the corresponding Ethernet address for those addresses. It also shows the type of address. Exercise 10 of 12. Viewing the ARP table. How can the ARP table be viewed on a Windows host? Now, you can view the ARP table on a Windows host by using the command shown here, ARP space -A. And this is the command here typed in on a Windows host, and this is the resultant output. Exercise 11 of 12. View interface index. How can the interface index be viewed on a Windows host? In this case, you can use this Windows commands netsh interface IPv4 show interface. With this being Windows, there's probably multiple ways to do this. This is one I found. Exercise 12 of 12. View ARP timeout value. How can the ARP timeout value be viewed on a Windows host? You can view it using this command netsh interface IPv4 show interface and then the actual interface index number. So using the prior command, you could gain what interface index numbers were available. Using this command, you could check a particular interface index number. Here within the output, you see these settings here. This is actually a wireless interface apparently that's being checked. But it shows you the state is connected, you know, the metric, also the MTU. Metric and MTU were covered in prior lessons. But we see here this reachable time currently is set to 35,000 milliseconds, which is actually 35 seconds. So it's using a multiplier that's between, you know, 1 and 1.5. You see the base reachable time, as revealed earlier, 30,000 milliseconds, which is that 30 seconds I told you about. Notice the reachable time varies from what the base reachable time is by a random multiplier. So there's a good chance if you check on your system, you should see a different value here for reachable time. That is if you're using a Windows system. Learning verification. Now we'll go over the questions you should have been looking at while we went through the studies and what you should have learned. So you would be able to answer all these questions. So example like what hosts use, what do hosts use ARP for? You know, what do hosts use Ethernet addresses for? You know, what's the destination Ethernet address when a host needs to send traffic to a host that's in the same subnet, or when it needs to send traffic to a host that's in a different subnet, another subnet? And we did have examples, and there were pictures included also. So if you need to review that, you can just, you know, go rewind that video and check that out. Now, can a host communicate to another host that does not have an entry in the ARP table? This was covered. Now, as an end user, is the MAC address of a website such as google.com useful to you? Why does ARP timeout cache entries? You know, why would you time that out? Why does the reachable time vary between 15 and 45 seconds on Windows? Now, what entries are present in an ARP table on a Windows host? How can the ARP table be viewed on a Windows host? How can the interface index be viewed on a Windows host? How can the ARP timeout value be viewed on a Windows host? And now we begin our summary. And this summary should summarize everything covered in the lessons. So in summary, hosts use Address Resolution Protocol, ARP, to translate IP addresses to Ethernet addresses. Hosts use Ethernet addresses for host-to-host communication. A given host X will use the destination Ethernet address of host Y to send traffic to host Y in the same subnet. A given host X will use the destination Ethernet address of host Z, its default gateway, to send traffic to host D in another subnet. If these are slightly confusing, please refer to the diagrams included earlier. A host can communicate to another host that does not have an entry in the ARP table via a broadcast communication. Broadcast communications are very inefficient. Actually, I should actually specify here. I probably should have specified multicast communication, because you can send a communication to more than one host, and as broadcasts are just another type of multicast communication. So if you catch that in the comments, thank you. Now, most applications will not work via broadcast and will instead work via unicast. For these applications, the host will not be able to communicate without a corresponding ARP entry. As an end user, the MAC address of a website is not useful to you. This will become more apparent once switching and routing are studied. ARP uses a timeout cache so that the information is not held indefinitely. Since stations can come and go from the network, other stations could pick up that same IP address. ARP helps to refresh that information periodically, as manually maintaining this network state information would be very labor intensive. The reachable time varies between 15 and 45 seconds on Windows because the base reachable time is 30 seconds and there's a random multiplier from 0.5 to 1.5. I gave a slight example here of 0.5 times 30 is 15 and 1.5 times 30 is 45. And that's where that range is. Now, so the caching could last from 15 to 45 seconds. And as we previously covered, the reason why you want this random multiplier is because you don't want all the systems to wind up refreshing their ARP caches simultaneously, as that could lead to a lot of additional traffic on your network. Now, we covered what type of information you usually see in the ARP table. As shown here in the example here, you can see the internet address, which is an IPv4 address in this example shown here, and also you see the physical address, which is the Ethernet addresses, also shown in this output. Here you see these Ethernet addresses shown here, and also you see these IP addresses shown there. And these addresses will correspond to different entities on your network. As seen here, this is your broadcast. Obviously, these are other multicasts. Note, broadcast is a type of multicast. And also we have this dynamic entry here. In this example, this is actually this host default gateway, and the actual host address is actually shown here in this example. And also the command ARP space -a is the command you use on the Windows host to view your ARP table. Now, this other command we covered, you can actually view your interface index values. We used this command in prior lessons. This command is netsh interface IPv4 show interface. And in this example, we were primarily concerned with viewing interface index values. Like see here, this index value 12 corresponds to this wireless network connection here. In a prior lesson, we covered metric and MTU, so if these columns are slightly confusing, you can refer to the prior lesson. On our final summary slide, we actually could view the ARP timeout value that's currently in place on a system by using this command netsh interface IPv4 show interface and then the actual interface index value. So the prior command on the prior slide, you viewed what your interface index values were, in this case 12, and then you could query this value to get other parameters of this interface. Here, you can see metric and MTU. What we're interested in here is this reachable time value, which I noted previously is a value that is randomly generated somewhere between 15 and 45 seconds based on a random multiplier applied to this base value of 30 seconds. This 30,000 milliseconds is equivalent to 30 seconds. If you need to verify, just use an online calculator. All right. Thanks everyone for viewing this course. I hope you had fun and enjoyed it, and I hope you stick with this series.